If we ever get to move to Mars, will we be stronger and faster because we're accustomed to Earth's gravity, like John Carter of Mars? So are we stronger on Mars? There's the real question.
Yeah.
When we get there.
That's an odd question to answer. Because
Okay.
the question is, are you stronger than what?
Right.
Okay? If two of y'all go from Earth to Mars, whatever your strength ratio was here on Earth,
It's going to be that
it's
on
going to
Mars.
be that on Mars. If somebody can kick your ass on Earth,
Right.
they're going to kick
You're just getting a Martian ass whooping.
I'm just saying, in terms of strength. So we have to be precise about how we're going to answer that.
Right.
Okay?
How much stronger will I be as an individual once I land on Mars?
All right. So we got to benchmark it. So let's say on Earth, you can lift 100 pounds.
Okay.
Okay? We have to ask, what does that 100 pounds weigh on Mars? Weighs 40 pounds.
Right.
So on Mars, you can lift more than your 100 pounds
Right.
because it doesn't weigh as much, not because you're stronger.
Exactly.
Okay,
Yeah.
I'm just am I clear about that?
Oh, absolutely. Yeah. So I'm getting that 220 pounds that I'm lifting, but it doesn't make a difference because it's really still 100 pounds.
Well, on Earth,
On
it's
Earth.
100 pounds.
Right, it's still 100
So you are
pounds.
not actually stronger
Right.
if everything you're lifting weighs less.
But the stuff that I bring from Earth to Mars,
Yeah.
which probably won't be a lot because the truth of the matter is you're going to print everything that.
Ideally,
you're
it's
gonna
called
print.
in situ resource utilization.
Ooh, I love it.
ISRU.
ISRU.
Yeah, it's a whole branch of NASA.
In situ resource utilization.
In situ, getting all Latin on you there.
Yes,
Okay.
exactly.
So they don't
in
want
the situation.
they don't want to have to carry everything.
Right.
Because that's very costly for the payload of any rocket.
Right.
We did a rocket equation explainer one time.
Yes, we did.
How quickly do you need more and more and more fuel to carry the fuel that you haven't burned yet
Exactly.
to carry the excess payload that you're trying to take.
Right.
So if that's what it is, then you would be 3D printing it on Mars, using raw materials there.
Absolutely.
Yeah.
So now, let's just say I need an object, and here on Earth it weighs 200 pounds, and there on Mars, when I print it, it's going to be the same, like 200 pounds, but it won't be. It'll be Martian, much less.
Well, it'll be Martian weight.
It'll be Martian
it'll
weight.
be 80 pounds.
80 pounds. And
Okay.
so I'm going to be able
80,
to...
I can do that right?
Yeah, 80 pounds, because 100 is 40.
Mhm.
So it's going to be 80 pounds on Mars, and... So really, it doesn't make a difference.
That's why the question...
It just doesn't make a difference.
No. So here's something that matters.
Okay.
If you're going to build something
Right.
structurally, it doesn't weigh as much on the supports.
Okay.
So you can build
bigger, stronger structures.
Bigger structures
Right.
in lower gravity
Right.
than you can here on Earth.
Cool.
Yeah.
All right.
And anytime gravity is less, you can do more.
Right.
So look what our mammal branch of the tree of life has done when we entered the water. When we entered the water, but how much do you weigh in water?
I don't know.
Zero.
Nothing.
You're neutrally buoyant.
Right.
You'll slowly sink
Right.
or you'll slowly float.
Right.
But basically, because humans, depending how much fat to muscle density you have,
Well,
okay.
Let's not talk about that. Okay. Please.
But some will sink and some will float. So
Right.
on average, we are the same density of water as we are of water. So in water, we don't weigh anything.
Mm-hmm.
Okay? Put a scale in water and stand on it and read it. Okay? That's what I'm saying.
Okay.
So when you don't weigh anything, then structurally, you're not putting yourself at risk. And that's why the largest creature there ever was is a mammal, and it lives in the ocean.
Right.
It's a whale,
Right.
the blue whale.
That's it.
We got one of those hanging
In the museum.
In the museum.
Yes.
Okay.
And by the way, it says all the time, my back is killing me because there is no water here.
held up.
These hooks. I can't believe the gravity that I'm feeling right now.
So when they say how much does a whale weigh,
Right.
the answer is zero. They give you a weight, and how do they give you a weight? They take it out of the water,
Right.
put it on a scale on dry land,
Right.
and then it weighs gazillion tons. But that's not the weight that the whale feels as it moves through the ocean.
There you go.
Now, there's another side of this, not to just make a long answer longer, but your weight is whatever is the attraction of gravity is to you, okay? Your mass Doesn't change.
Doesn't change. Right.
Doesn't change.
Right.
Okay? Mass is count up the molecules in your hand, in your
Right.
body, in
Right.
the rock. The mass is the mass. The measurement of a mass is the same no matter where it is in the universe.
Okay.
Okay?
Nice. All right.
Wait, unless it's moving relativistic speeds, then the mass increases. But holding that aside,
Right.
that's a different conversation.
Okay.
Okay? But mass matters with regard to momentum.
Right.
Okay, so watch. If I take a 100-pound brick and I throw it at you,
I'm suing you.
it'll knock you over.
Yes, it will.
Okay? Now, so how much mass is in the 100-pound brick, we can ask.
Right.
Okay? You can measure up that mass. If I pick up that brick on Mars, it only weighs 40 pounds. But if I throw it at you,
The mass is the
the
same.
mass is the same.
Right.
It'll knock you over in exactly the same way it would have done it here on Earth.
Right.
Just-
Okay.
Just so you know.
Follow to learn more.